right, everybody. Good morning or good afternoon. I don't even know what it is. Is it afternoon? Good. Good afternoon to all of you guys. All right, let's see what we're doing today. I got to go back to here. You guys are in 262 yet? You will be. I want to share with you guys some notes here. Okay, so if you guys print this up at home or anywhere, or maybe you go back and watch this stuff, hopefully, I don't know. Hypothesis testing procedure. So we're going to have to start to dive into one of the most beautiful topics ever. And in case you guys didn't know, what's going on here? Where is the people at home? Where are the homebodies at? Let me double check here. Okay. Copy. Did I put it in the right place? You never know. I just got my coffee this afternoon. Let's double check. Today's the 10th, isn't it? See, ends in Y. Yeah, we are updated. Just double checking. Yeah, we were good. All right. You guys are my witness. We were good to go. Anyway, well, we do have some people there. So anyway, okay. So ladies and gentlemen, let me start this lecture today because this is a beautiful topic. You guys want to be educated on this stuff because it's really the scientific method. But it's applied, in other areas too, right? It can be applied in a lot of different areas. Do you guys know, just kind of to start the discussion, do you guys happen to know what's the secret to getting an A paper since you guys are college students? And anybody here get A papers? What's the secret? I was a kid who didn't even want to go to college. I didn't know how to study. I had to learn how to study. I didn't even want to go to college. I was forced to go to college. Darn it, reluctant. I became an excellent student, ladies and gentlemen. Unbelievable student. Who knew? Who knew? I was winning awards. I got the Outstanding Graduate Student Award, meaning the best graduate student in the department. That was me. So I became a study what? A study hog. I don't know. So I found some secrets along the way. I didn't know this. What's the secret to getting an A paper? Do you guys know what I mean? What's the secret? There's a secret. I couldn't believe it when I discovered it. You ever talk to people and you ask what their opinion is, and they tell you an opinion, and then you ask them why? You know what you sometimes hear? You hear one word. Because I think this, because that's not a what? That's not a reason. Okay, you guys know what I mean? So that tells you something. If you said, why do you have this opinion? And you just go, because you're not going to get an A paper. Okay, you guys know what I mean? It ain't going to happen. In fact, you can even say, well, I wrote down a lot of reasons here that for how I feel, and then they still gave me an F on my paper. They handed it back. Has anybody ever had that happen? You get confused. You go, but I submitted 3 pages and I got an F or a D. Yes. And oh, okay. Well, then I'm going to be careful with my comments. Here is the thing. What I figured out was you got to justify your reasons. And they better make sense. I'm going to say that again, ladies and gentlemen. You got to give a justification for what you think, and it has to be logical. Otherwise, what can happen? They can write it up and they can send it back to you and they can frustrate you and they can make you angry. But once I figured that part out, I go, oh, yeah, okay, all right. My papers were A's. But it's going to make you now have to think. It's going to make you have to go back and dig up and get the evidence and everything. And you're going to have to make it a logical statement. You got to really work on that. But the reason I bring that up is because it's related to what we're talking about, right? If I were to say to you guys, do you know what a hypothesis is? You ever heard that before? What's a hypothesis? Well, it's good. That's why you're here. You're here to learn. It's an educated guess. I like the phrase, an educated what? Yes. And even that phrase, an educated guess? Just the meaning of that, just that phrase, an educated guess. It's not a random guess. It's not just guessing randomly. That word educated guess implies there's some what? Some knowledge or past experience behind it. There's something there to it. Okay? Now, in statistics, a hypothesis is an educated guess about a population parameter. Do you guys happen to know what are the population parameters? We just got through working with those things in estimation. What are the population parameters? A proportion, a mean, a variance, and a standard deviation. There are these 4 measures that come from a population. Okay, so in statistics, it's not in general an educated guess, but it's an educated guess about one of these values. It's a hypothesis. That's the meaning of it, ladies and gentlemen. And this word, hypothesis, informally is known as a what? Claim. Have you ever heard somebody say to you, hey, what's your claim? They're saying, what's your hypothesis? Anyway. Educated guess about a population parameter. P, mu, sigma squared, sigma. Okay, what do you guys think about that? So I'm about to give you guys, we're going to dive into this because this is where I say to people that statistics is about language and process. So I have to give you guys language and process. The language isn't that bad, though. You guys will see that. I never thought it was that bad, but okay. So here's what I want you guys to know. I'm going to give you guys some words here, some things to think about, right? If I said to you, as an example of hypotheses. All right, here we go. The proportion of students who smoke is, what? 35%. Now, I don't know if it was us that talked about this in the past. Maybe, maybe not. Anybody here smoke? Where are the smokers in the room? You guys smoke? Yeah, exactly. Exactly. In the old days, this was a little taboo. Today, not so taboo. So I'm going to say anything. It doesn't matter. Okay. It doesn't matter. I drove by yesterday this cannabis store. And I was, I didn't get anything. I drove by it. I was on the way to actually dinner. My daughter called me. I'm very lucky. I have this relationship with my daughter. It's an unbelievable relationship. She says, Dad, I want to come see you. I said, okay, come on down. Of course, she's hungry. She likes, she likes dinner. Daughters do. So do sons, I think. Sons like eating too. If I had a son, I think I'd have the same relationship. But anyway, so as we're driving to dinner, I drove by this cannabis shop, so I didn't stop. But I was like, oh, that's interesting. And I don't even know all the rules and regulations behind it. But anyway, it's kind of, it's an interesting thing. So no big deal. No big deal, ladies and gentlemen. Trust me, I don't look at people because they smoke and go, okay, what am I going to, I do know one thing. There's that, what's that cream that you put on some achy? Yeah, that stuff works great. That works good. I like that. Huh? I just put the cream. No, the cream. Like sometimes, I had a buddy. He puts it on his 80-year-old mother or something. Like she has her arthritis problem or something, and he puts the cream on her or something, and she's like, "Whoa, what's in that cream?" Because it works really good. He doesn't tell her what it is. But I've had the cream. I put the cream on some achy joints. Okay, I take it back. I have taken some gummy bears to sleep, but they're supposed to be THC free or something. I don't know. It's the stuff that's supposed to be without the good stuff. I don't even know what's in it, but it's gummy bears. It's too expensive. So I used to take it to go to sleep. At first I was fine, and now it's like, I'm not going to spend all that money on that. But anyway, proportion. Can I ask you guys a question? What parameter is that? You got 4 choices. Is it P? Is it mu? Is it sigma squared, or is it sigma? How do you know it's P? Thank you. Is that simple? Now I'm gonna go into some S. You might say, what is some S? Well, this is a statistics with support. So let's get out of this statistics realm. I'm gonna go back to some algebra. You see that phrase right in there? So go back to algebra, ladies and gentlemen. We got to do some little algebra here. It's actually language. Do you guys remember some phrases? Here's some phrases. Is the same as. Equals is equal to. These are all some phrases. What symbol is represented by that? Isn't that your equal sign? You guys okay with that? I'm going to put an equal here. And then, what's this over here? This is what? 35%. So, I want you guys to not just read the phrase. You're going to have to translate this symbolically this way. Read it left to right. The proportion of college students who smoke is 35%. I want you guys to transcribe that because that's an example of a hypothesis. You guys okay with that? And so I'm just giving you guys examples here, but I'm going to have to dive in and out in purple into our S portion here, right? I'm going to say this as well. The mean age of college students That's the mean. That's the average. Is not 22 years. Okay, this is another example of what? A hypothesis. But when you read this, you guys see the word mean? Which one of these parameters now am I talking about? It's mu. How do we know it's mu? Because that's the symbol for the population mean. So this is what they're referring to. But when you read this phrase, is what? Is not 22. We're going to have to dive into the S again. Go back to algebra. So you go, okay, what do we do in algebra again? Okay, you have is not the same as. Is not equal to. Is not equal. Ooh, I'm going to put this other phrase. Is different. What math symbol from algebra are we talking about now? You put the equal with that slash. Isn't that not equal? Not the same? That's from algebra. This is the S portion. So, okay. So you might say, does that mean symbolically that this is saying what? Mu is not equal to 22. Here's another one, ladies and gentlemen. I'm gonna stick with P and mu today, but I can write, and you'll see some of my notes. I'm gonna have other variance and standard deviation. Those have hypothesis tests as well, but I usually don't cover those. I cover P and mu. There's only so much test we can do. We can do a lot, but whatever. How about this? How about this statement? The proportion of what? The proportion of students who take a full load, 12 units or more, is less than 65%. Okay, all of this here this is another hypothesis, right? But what's the parameter when you guys read it here? Right? What does it say? Proportion. Okay, so, what parameter's there? Isn't that P? Okay, now what's the key phrase you guys see here? Is less than what number? 65%. So algebraically speaking, all right, what is this? We got the word from algebra, less than, smaller than. Anybody remember that symbol? What was that symbol from algebra? Less than, smaller than, what is that? Isn't that less than sign? Okay, isn't that the less than symbol? So we've actually been using these symbols, if you guys haven't noticed. So P is less than what? 65%. I want you guys to know that. This is important. All right. Is that easy? What do you guys think? Is that pretty simple? Okay, how about if we say the mean lifespan of a Dodge Challenger is more than 8.5 years. What's the parameter? How do you know it's mu? The word mean. Okay, good. You guys okay with that? So the mean lifespan of a Dodge Challenger is, what about this phrase here? More than? More than 8.5 years? Okay. Let's go out to some algebra. If you see the phrase greater than, if you see the phrase what? More than. What symbol do you use now? Isn't that the greater than symbol? Haven't we been using those symbols here? Because we have. I've been using them, then talking about. And in fact, all of this word, all these phrases should be very familiar. Okay? These phrases should be very familiar. So this is going to be mu greater than what? 8.5. Symbolically. Easy peasy, lemon squeezy. All right. The proportion of female college students is at least 60%. The proportion what? P. What's this phrase? At least 60%. What is that going to be? P is what? Greater than or equal to what? Oops, sorry. We forgot to do the algebra. If you see the phrase at least, right? What does that mean? Isn't that greater than or equal? Haven't we been using that for a very long time? So in some ways, ladies and gentlemen, nothing's new other than reading the statement and writing it down symbolically. That's what I think. Am I wrong with that? Haven't we been using these phrases from the beginning at least? First week, my God. I think I even said this. I said, if you guys understand this now, wonderful, because you're going to be seeing these phrases over and over again. I also said, if you don't, start to learn them, get them in your language, go to Jack in a Box and order at least 4 Jumbo Jacks. You know what I mean? Get it in your vocabulary, because you're going to see this, and this comes down to just language and process. Okay. And I think I have to put this. Yeah, we did. Okay, this is the next phrase I'm going to say. The mean what? I don't know if I want to say, because by this time I'm beaten down already. You guys don't know. You know, this is Mr. Judge. He's kind of slumped in his chair. You know what's funny? At like 7:15 a.m. in my trig class, sometimes I have like 3 students there. And then, but you know how many students come to the day on the day of the test? Like 33. I'm like, what? Who are all you? And they're actually doing really well. I'm like, man, these guys are doing really well. What the hell? They're not here. Today I started my calculus lecture. You know how many people were in my calculus lecture today? In class when I started? 0. I'm like, what? You're supposed to only be, this is only if you get COVID or if you can't make it. Nobody can make it. Anyway. But there's like 28 homework assignments I have to grade today or this weekend. I don't know. I think it's convenient, in all honesty. I don't mind doing it. This is why I do it. This is the madness I got to do. I've been doing it since we came back from COVID. The schools kind of got on board, which is why they installed all this stuff. So they're going to do the same thing I'm doing. So they're going to do what I'm doing. So I guess this is the new normal. Flexibility. I'm not against flexibility. Flexibility. The new normal. Is it convenient? Yeah, what if you had to go? I don't know. Like for me, it's kind of convenient. I mean, it would have been. I don't know. If I was a student, I don't know if this would have been good for me. Maybe. I probably would have showed up anyway. Because if you're kind of mature, you know what I mean? You're not like going, do I go to class today or not? Or play my Xbox? I think I'll play my Xbox today. You got to make those decisions. You know what I mean? Do I play Xbox or do I watch Netflix? There's nothing good on Netflix anyway. What else you guys do? Xbox, Netflix? Do I get on Instagram the whole day or TikTok? Do I do my TikToks? I don't know. No. Get out. If I even recommend get off social media. You might find that you might be happier. Yeah. Do you guys know that? There's research on this stuff. Do you guys know there's a correlation, we're going to get to that too, between people who are depressed and people who are connected via social media? Has social media made us depressed? Does anybody know anything about this? Have you heard about it in your other classes? You guys get to talk about that? No? Supposedly social media is making us depressed. We're supposed to be more connected and we're more disconnected. How could that be? You ever go to dinner and everybody's on their phone? You guys know what I mean? You're going out to dinner and everybody's on their phone. How about at home? You have dinner at home and everybody's on their phone? You guys know what I mean?
10, 15 years ago, it was like, oh, you younger generation's always on phones. Now it's the older generations are 20, 30 years older. They're all the ones on their phones.
Yeah, it's interesting. You know why, I think? Like for me, I hate to say it. I'm one of these guys. I'm on my phone during dinner. My wife's, can you put that phone away? I was like, no. Mm-mm. Can you talk to me? I was like, I shouldn't say this, but I'm going to. I'll talk to you if you don't complain. But if you're going to start complaining, guess what? I'm gonna get on my phone. Isn't that horrible? We're on our phones and we're not as happy. Yeah, I'm actually thinking of just putting my phone down when I get home. I am actually thinking about that. Seriously thinking about it. Huh? I know, that's the thing. You guys don't realize too. Sometimes I can't sleep. I'll get an inbox message. respond like at 4 a.m., 2 a.m. And some students are up. Hey, you're up at that early? Just waiting for your messages. Isn't that horrible? No, I'm not. I had that conversation with my daughter last night. I said, Ashley, yes. Oh, I don't think I get any sleep, in all honesty. I think I don't get any sleep. Sometimes, yeah, I got to do. I'm doing way too many things. I'm doing a lot of stuff. I don't usually sleep. I get up like maybe 5:15, but I get up like at 3:30. Then I get spooked because I'm like, isn't that like the devil hour 3? So oh my god, I'm saying my prayers at 3, trying to get back to sleep. No, it's the devil hour. I woke up, devil hour.
Is that why you have the 7:15 a.m. classes? Because you get up so early?
Well, no, sort of. They gave them to me. I don't know why they gave them to me. They assign them, and then I usually started at 8 and everything, and at 9, and then they just assign them that way because I think it gets political in our department. Trust me, it's a lot of politics, and it's vicious.
You don't get to choose the hours?
Not exactly. They get assigned, but it's a weird thing. There's a lot of stuff going on. I can't really share with you guys the dirty, ugly details, but a lot of going on. Yeah, crazy. Because he had to get to his class at another campus at 11. He's one of those. One of those. We got him. They're vicious. Well, I think a lot of people are, because it's coming. That's why they installed this stuff. They didn't do it because they wanted to impress me, ladies and gentlemen. They did it because they're going to have what I'm doing now. They're going to do exactly what I'm doing. That's what they're going to do. But they're going to broadcast via Zoom. They're not going to broadcast like what I'm doing, Ecamm Live. They're going to do it via Zoom. But this infrastructure you guys see is designed to do what I'm doing. I'm just doing it with a laptop and an iPad. They got to have a camera and a projector. I mean, we need the projector, but they're not doing it really because of me, in all honesty. Although the president did say, he said, Daniel, you're light years away. You're light years away from ahead of everybody. I said, I think so. I have been, yeah. Because I remember the school couldn't put up a website at one point. Believe it or not, I had a website. I had a streaming server. It was a long story. Whatever. I can't get off of my tangents here. The mean what? Talk to my wife. Do wives like that? Do they like it when you talk to them?
Mm-hmm.
They do? Any wives in the room? But they like that stuff? I should try it.
What'd you get for Mother's Day?
When's Mother's Day?
It's
It's today. And I got to wish my mother-in-law when I get home a happy Mother's Day. I got her some sandals.
Were they ones that she likes?
She picked them out. No. Actually, thank God. That was my first wife. I didn't talk to her either. That was my first one. The second one, they're different. The first one, no. I learned that lesson. I learned that one. But the second one, she's opposite. They're opposite. No, I actually, if you guys want to know, I'll tell you. Believe it or not, Mr. Judge is really not so bad. He's not so bad even as a husband either. So okay, what did I do? You know what I like doing? I'll even show you a picture if you're lucky. I like going to San Diego for Cinco de Mayo. I like going to Old Town. Now, I don't even really know what Cinco de Mayo is. If you guys want to know the truth. Who knows? I don't think anybody knows. Not really. It's not really. It's really Drinko de Mayo. It's kind of like St. Patrick's Day. It's really a commercial holiday. And if you guys really want to know the truth, it's commercial. It's not. It's commercial. Mexican independence is not on May 5th. In fact, what I've been told is, I guess they kicked the French out of a Puebla. And I said, what's a Puebla? It's a county. Okay. When? May 5th. Okay. Do you celebrate it? Not really. But why do we celebrate it? It's Drinko de Mayo. But okay, I like going out to San Diego. They close down the street, Old Town. I eat at an amazing place. You guys know, anybody go to San Diego? Okay, I'm going to tell you where to go. You go to Cafe Coyote in Old Town. Best Mexican food you've ever had in your life. Even my mother-in-law looks at me and says, oh, yes. No, go to Cafe Coyote. I've never been there, but I've been to Cafe Coyote. Even my mother-in-law says, oh my God, she loves it. So I eat there, and we're going to hang out there. The Padres are in town. Dodgers are in town. I was thinking of going to the Petco Park and watching the Dodgers play the Padres, but the tickets were expensive, and for cheap seats, I didn't do that. So I watched it kind of in the room, and then I went to the Old Town to go celebrate Cinco de Mayo, whatever that is. I don't even know what it is. So if you're lucky, I'll share a picture with you. Yeah, Grito Dolores, I would tell you, Gabriella, go to Cafe Coyote, and I'll tell you what to even order. Get the carnitas, the carnita taco. Man, you didn't need to put anything on that. And they got the drinks there, and they got stuff there. So go there. So that's what I did. I took the old lady. I said, hey, I surprised her. We're gonna go spend the night in San Diego. We're gonna go celebrate Cinco de Mayo. I even take your mother. So you took her mom. What do you think? That's not so bad. My old lady? No, I don't say that stuff. I only say it for you guys because it's entertaining. But you can call it's old lady stuff. It's my old lady. It's just a phrase. But I don't call her my old lady. Mm-mm. I don't even say that. I don't say anything. I don't even say that. So, yes, that's why I keep my mouth shut. That's why I don't say anything. You're like, mm-hmm. That's why I don't say anything. But I don't. So yeah, we went there, and then I'll tell you too. What happened there after that? So yeah, we hung out in San Diego for the night, and then the next day had a nice breakfast at a great place there called Snooze AM. Great breakfast. Then we went out to I love going out here. You guys know when I go to the beach, I don't really go to an LA beach. Don't go to beaches in LA. That's not even a beach. It's like a sewer. Yes. Yeah, I go. Well, where I go is, I'll tell you a couple places I go. I got 2 places I go to. I head out to Laguna. There's great beach locations in Laguna. Trust me. Oh my God. And then where I go out in San Diego, I go out to Coronado Island. That's my place. Man. Coronado Island. And yeah, there's a dog beach in Coronado. You go out there. It's by the Navy SEAL base there. It's right next door practically. And there's a dog beach. And you see all these dogs running around. And in fact, I love San Diego there because people treat you well. Oh my God, by far. You kidding me? People were like beautiful there. They are. They're so wonderful. They're- yeah, Malibu. Yeah, I've done some photo shoots out in Malibu. It is far though. It's far, but I go to Coronado Island. I go hang out in Coronado Island. And then if you ever look at the neighborhood in Coronado Island, if you guys ever been there and you see that like the neighborhood in the houses, if you ever win the lottery, that's where I'm moving.
No.
You know that I told you already. That's probably why I'm not gonna. I was praying out there. Please let me live here. You've ever been there and you've seen it? You're like, this is. Every beautiful movie you've ever seen of a neighborhood and a home, that's there. And you're by the beach, and the weather is just so. Oh my God, it's better than Hawaii. The weather in San Diego is better than Hawaii. It's like heaven on earth. Heaven on earth. And people were nice. It's not like LA where you have to keep an eye on everybody. San Diego, I'll tell you, once we were in San Diego, we went down on a whim for a day. And it was a hot summer day, and we didn't have. We were in the sun. We didn't have an umbrella. It was hot, and we were, not too bad at San Diego. Do you want to know what somebody did? Somebody walked by, and they said, "Here, we have an extra umbrella. We want you to have that." I was like, "Well, thank you." And I told my wife, this would never happen in LA. Never. They would take our umbrella. Don't even go to the bathroom. Your umbrella, come back, your umbrella's gone. People gave you an umbrella just so you can be in the shade. Anyway, darn it. And then on the way home, what's the place you go to after the beach that you got to go to? Okay, Gabriella, you're going to write this down, Gabriella. You know where you guys go? If you really want to have some good ribs. You guys don't know? Phil's Barbecue. Oh my God. That's really why my mother-in-law wanted to go. She didn't want to go for the Mexican food. Although she says it's wonderful. She loves it. She loved her carnita taco. She gets what I get. Cafe Coyote. Coyote Cafe. It's voted #1 Mexican food in San Diego for like the last 25 years or something. Crazy. You go there, there's like 500 people eating. So big. Go to Phil's Barbecue. Isn't that good barbecue? Very good. My mother-in-law, she's like, we're going here before we go home. So give it to my mother-in-law. She gets some Phil's Barbecue. A really good barbecue. Yeah, if you haven't been there and tried that, put it on your to-do list. So Mr. Judge is not that bad. He just knows better than to say anything. He knows better than to disagree. He just says, okay. That's it. Okay. You guys know what I mean? You guys don't know that, but just don't say anything. Don't disagree. Don't argue. Don't fight. Just say, okay. How about this? The mean number of ex-wives for statistics instructors is no more than 3. All right, you guys okay with that one? What does it say? The mean, what's mean? Mule. What's the key phrase? No more than 3. Let's get out the algebra. Okay, when you have no more than, you guys remember that? What was that? That's actually less than or what? Equal to. This is the less than or equal to sign. That's the no more than. You guys remember that? We've been dealing with that. So here's the deal. We're saying mu is less than or equal to what? 3. Okay, you guys okay with that one? Ah, I was right. Anyway, so Mr. Judge is not that bad. He's actually pretty good. He doesn't even argue. He doesn't. He just says, okay. Is that a sign of a Libra? Okay. Says, can you get me these sandals for Mother's Day? Okay. Would you like another pair? No? Okay. A dog stroller? Oh my God.
We have a senior dog. She loves that old dog, so she keeps saying, I want a dog stroller. So we're like, you sure you don't want like a nice bouquet of flowers? She's like, no. Like my dad even texted me right now. He's like, Ivy, your brother and I are looking at dog strollers on Amazon. You want to go split with them?
Get the dog stroller. Is it a big dog or a small dog?
It's a weird. It's a Dutch Hound weenie dog.
Kind of small then.
Pretty small. She's fat now. Very old.
Very old?
She's very old, and weirdly enough, she's fat up here, but she's very skinny on her back.
Look, this world is big, and you know, there's a lot of different things that people like and want to do, and I guess that's okay. Dog stroller. Anybody else? What are you gonna get for your mom on Mother's Day? Shoes. What are you gonna get your mom?
A nice dinner and flowers and chocolate-covered strawberries.
What are you gonna get for your dad?
It's on Dad's Day.
But if it were
If it were,
Father's Day,
scale it back a bit. Maybe we do.
hmm.
Maybe a nice dinner, maybe. And then I guess I could get him flowers because guys never get flowers or whatever. And he doesn't need the chocolate. He's diabetic.
So am I, by the way.
Oh my God! How come you didn't tell me when I was getting you all those pies?
Because nobody listens to me anyway.
Oh,
Okay, good. You know what my wife packs me for lunch? Candy. Whatever candy she can't get rid of for Halloween. Stuff nobody wants.
there's no way you still have Halloween candy.
That's what I'm thinking. I'm like, how come she doesn't understand this and can't do the math? Why is there a peanut butter and jelly sandwich in my lunchbox? Why does she put some chips? These are all things I love, but I can't eat. She puts things I love, but can't eat. I've thought about that. I was like, oh. What do you get a father? Skateboard? I don't know. Dodger tickets. There you go. There you go.
Okay.
What about these hypotheses, ladies and gentlemen? We're going to have you guys test you. Test you guys on this. Give you guys a few minutes. Try this out. let's see what you come up with. Let's get this off of mute. Okay, let's try this out here. This is really the first step in hypothesis testing. What you guys are doing is we're working with the language part, and here's the language part. The mean lifespan of California residents is what? Okay, what do we write down? Isn't this mu? Mu what? Equals. What do you guys think? Is that pretty easy? Okay. All right. What's the next one? What does this say? The proportion of college students who take a full load, what is this? Is not what? 40%. What do you guys do? P not equal to what? 40%. Did you guys get that? It's pretty good. Okay, what about this? The mean pulse rate of males, that's mu, is what? Is at least 72 beats per minute. This is for some of those nursing majors or whoever, right? How do you represent at least? Greater than or equal to what? 72. Believe it or not, males and females have different pulse rates. Boys and girls have different pulse rates. The what? Standard deviation of IQ scores is, what's the word? Less than what? 15. So standard deviation, isn't that what? Sigma. Less than 15. The variance, now we're going to use that symbol for variance of IQ scores is, what's this phrase? More than 125. Okay. We're going to write variance as what? More than what? 125. Oh, is no more than, thank you. That's going to change things. No more than. How do we represent that? Less than or equal to what? 125. Okay, now what about the last one? The probability that the Dodgers will win the World Series in 2021 is more than 1/2. I guess I wrote this 2 years ago. P. How do we represent more than? Is that greater than? And how do I represent the word 1/2? Good job. What do you guys think, ladies and gentlemen? Is that pretty good? All right. So that's a fascinating thing. Now, I want you guys to understand something here because I'm going to go to this next definition here. Okay. We have two types of hypotheses. There's two types. We have what's called a null hypothesis. So I'm going to use orange here for null hypothesis. The symbol is H for hypothesis with a subscript 0. So here's your definition. It's a hypothesis that involves a what? Condition of equality. Okay, this is the definition of it, but you want to know what it really means? If in the hypothesis you have the what? The equal sign, the greater than or equal, the less than or equal, well, then that's a null hypothesis. H naught. And like I said in the chat, I put the notes. It's also online on my website if you guys want to download those notes. When students actually when I teach these online classes, I always put these links in the chat, and I have those students actually they download and print the notes and they use them. Anyway, definition of what we call an alternate hypothesis. H1. An alternate hypothesis is a hypothesis that what? Does not involve a condition of equality. So does not involve condition of equality means there's no equal sign. No equal. No equal. So not equal does not involve equality. Strictly greater than and strictly less than, all of those do not involve equality. So ladies and gentlemen, this is what you guys want to identify. You guys okay with that? So if I went back over here and I said to you, okay, we're going to put H for all of these here. Which one? What can you identify them? Yeah, is the first one, what's the first one? Is that a null hypothesis or an alternate? It's a null, and you say why? Condition of what? Equality. The second hypothesis, what kind is that? Alternate. You say, how do I know? Because of this one. What about the next one? What kind of hypothesis is this? It's a null. And you say, why? It involves a condition of what? Equality. What about the next one? This is what? Alternate. You say, why? It does not involve a condition of equality. The last one, what's this? Oops. It's a null because it involves a condition of what? Equality. And then this last one, sorry. This is an alternate. Why? It does not involve a condition of what? Equality. So I want you guys to really take a look at these here, because we're going to have to know what kind of type of hypothesis we're dealing with. Okay, so there's your definition in the notes. Okay, now I'm going to say this to you guys here. I'm going to kick this up. These are some more hypotheses to interpret, because sometimes when students have read these kind of questions that involve this, they get confused and they go, I don't know what they're talking about, Mr. Judge. So we're going to try to figure this out. So if I said, take a look at the first one there. If it says 52% of newborns are what? Are baby boys. If I had to write it down, I'd say 52%. If I had to do it again, 52% of newborns are boys. Would be obviously they're a baby if they're a newborn. So what does that 52% represent? What parameter is this? That's the real question. Students may not know the parameter. So if I said to you, guess what? 52% of newborn babies are boys. Yes, good job. That's a P. Think of proportion, percent, probability. That's all the same thing. And if they just say are boys, what inequality is this? Equal to. There you go, ladies and gentlemen. What do you think? Okay, I know sometimes they word it this way. And I'm saying to you that because if you ever read articles at times, if they have a hypothesis, they might say the title 52% of newborn babies are boys. That's a hypothesis. Do you guys know what I'm saying? It's like a headline. Hey, 52% of newborn babies are boys. You may find, ladies and gentlemen, that it is not a 50-50 chance of having a boy or a girl. In fact, oh, you're really going to like this. You guys know after World War II, there was a greater percentage of babies who were born that were actually female over male. No. Sorry, I take that back. There was a greater percentage of newborn babies who were male and not female after World War II. That's a good question. Why? It's almost like the world was saying there's been a lot of men who were killed. There's a lot of women killed too. But a lot of men died in the war. So it's almost like nature of the world was saying we got to regenerate that loss. I have no idea. I have no idea. All I know is the story behind it. It's like, okay, after World War II, there was a greater percentage of, and I forget, I think I might have read it out of a version of Triola, our textbook. He might have put it that. That's where I might have got some of that. But I just want you guys to know it's kind of an interesting thing. I've always thought of it that way. Like, wow. What about this? 64 what? Percent of college students believe Bigfoot is real. What's the parameter here? P. And what does that mean? P equals what? 64%. Okay, what about the next statement, ladies and gentlemen? What's this? Earthquakes occur at a what? At a mean depth that is not equal to 5 kilometers. What does that mean? Mu what? Not equal to 5. Maybe you're a geology major and you care about these details. Any geology majors in the world or in the room? What's your major? Oh, then we got to do a psychology. How about this one? That's kind of somewhat related to psychology. Actually, the last one's more related to psychology because they like talking about IQ scores. They're the ones that define this. The mean IQ score of college professors is what? No more than 125. This is the mean. This is the average. What do I write down, ladies and gentlemen? Mu. What is no more than? Less than or equal to what? 125. No more than. That's 125 or less, if you guys remember that stuff. Now go back to this. This can be thought of as somewhat of a psychology, sort of related to maybe, but it could even be a nursing kind of a example. What if it says insomnia treatment with zopiclone? You guys know what insomnia is? It's when you can't sleep. What is it when you can't stay asleep? Huh? Yeah, insomnia is where you can't fall asleep. What does it mean if I keep waking up at 3 a.m.? Yeah, I know. What's up with that? I know. Me too. Isn't that weird? Awful. Awful's the word. That's what I say. Is it anxiety? Oh my god.
Waking up at 3 and 4.
Yeah, if you keep waking up at the same time, like three,
That's just
3:30
when, the brain's most active.
at 3.
For most people, like your body is just registered to start getting up before everything else starts getting up, if you will.
Mm.
It's kind of like a survival kind of thing too, getting you ready.
I thought
Part of it.
I thought that was like the devil's hour, and
No, that's party hour.
is that party hour 3:30?
That's party hour.
What if it's like 3:33 or something? That's like, oh no, is that the worst time? 3:30.
You like prepare yourself to go to sleep properly. There are ways to prepare yourself to like get a good actual rest.
What is that? I'm just curious.
I know like you're supposed to start turning off lights like 2 hours before you go to bed, and not really look at like blue light screens too much and stuff like that.
That's what I'm thinking. I'm thinking of just like when I get home, I'm not getting on my computer. I'm not looking at my phone. I'm just calling it a day.
Until you get a message from one of us.
That's the problem. Then now I get all these messages. And I'm like, oh my god. Now you have all these emails, and like you guys know, I think emails like the worst. I just hate it. And you have to do like 20 emails a day, and you get 20 emails a day. I hate it. I'm like, you know what? I'm done. I'm gonna join the non-working world. No, they all just quit and just left. Where did they go? You guys ever hear that? People, you guys know there's like a worker shortage because people just stopped. And the pandemic, they just all stopped. They said, nope, I'm done. It's like, wow, where'd they go? Huh? They're on TikTok. Can you make any money on? You can?
Not
It's not really
anymore.
low now. It's like a penny, 50,000 times.
No, so you know how there was a whole ban on TikTok hysteria going around? Well, apparently the bill didn't get passed, but what did get passed was a edit to like the terms and agreements, so you can't make any money off of it. What in the world? If you make music on there, like you know how people put original music sound on there? If it starts making money, the app can take it, make its own version, and profit off of it, and you won't get any royalties from it. What in the world?
That's crazy. There was a law that passed that does
I
that.
think it's a bill for it because there was a whole like trial going on about like where I think the CEO of TikTok came all the way from China to be in a hearing, but it was it was a joke, and I think it was really just to kind of put heat on like this joke of a trial, so that the bill, the major part of that bill, like that, the money making part was looked over.
Don't know. I just thought I was gonna make some money on my YouTube videos, math videos. I'm gonna have to get more than 1 like for a change. I'm probably gonna have to get more than 5 views. Maybe that's why I have that insomnia. Well, if you take this medication, you have a mean wake up time that is what? Less than what? 103.2 minutes. So, mu less than 103.2 minutes. What do you guys think? Is that okay? Is that kind of straightforward? If I asked you, can we now identify yet again H, 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 and H? What kind of hypotheses are these? The first one is what? What is that one? Is that a null hypothesis? Because it involves a condition of what? Equality. So I'm going to put in orange. Equal. Less than or equal. These are all what? Nulls. Is that true? Less than, and then what? Not equal. These are your alternates. What do you guys think? And that's kind of, in some ways, that's your first obstacle. That's the hard part. Okay, now what I'm going to do here is this. This is going to be kind of interesting here for you guys. What we're going to focus on now, there's a hypothesis testing procedure here. So I wrote these notes. Your hypothesis testing is based on really, here's the idea, right? Somebody makes a statement. These are all claims. And remember, you're now going to have to test these claims. And how you really test it is by going out and taking a sample and computing a test statistic, a formula. Now, the good news is back in the day, I used to have students use the formula in the calculator. And so you'll see the formula. I'll show it to you, but not a big deal. We get to use our TI now. So all we do is put sample information into our TI, and we can actually compute that test statistic and see where it lives in our decision rule. Now, the thing about it is there's 3 different decision rules. There's 3 types. I focus in the beginning on the two-tail test. And you go, what? Yeah, we're going to focus in the beginning on you got to do this, and you got to do this stuff in pieces here, ladies and gentlemen. Like if you had to eat a steak, you cut it in pieces so you can chew and swallow. So we're going to focus on the two-tail test today. The procedure in 2 tails. But I have to let you guys know, right? We have to work on creating what's called a decision rule. Because here's your steps. You might say, what are my steps in hypothesis in the procedure? Well, step 1, you're going to set up your hypotheses. We're going to go through every step, of course. Step 2, you create your decision rule. So, in all honesty, you say, what's the hypothesis setup? We'll see, but I'm going to write this down in your notes. And then your decision rule is going to be your bell-shaped curve. It's going to be your Z distribution. So when you start doing this stuff, you're going to draw that decision rule. It's your bell-shaped curve here. So you're going to create a decision rule, but you're going to need to know something called the level of significance alpha. Okay, it's called alpha, the level of significance. I'm going to give you that detail. Okay. Now, what's related here, so you guys know, I'm going to write this down here. This is the setup, the hypothesis testing setup I just described in that. This is the setup of your hypothesis. That's your step 1. And once you set that up, you're going to create a decision rule. But this is what I want you guys to notice here. You're going to look at the alternate hypothesis, and if you see a not equal here, that's going to be the tip-off that you have a what? Two-tail test. So in all honesty, in general, the alternate hypothesis, H1, will always give you a two-tail test. Now you might say, what's the relationship between the null and the alternate? Well, they're opposites. So I'm going to say H0 and H1 are what? Opposites. So it may not look like it makes some sense to you right now. So let me give you guys a question here. And we'll get back to our notes. Like if, for example, if they said to you, we're going to start off with a two-tailed test situation. The proportion college students who have a TikTok account is, what do you guys think it should be? 70%? As claimed by Snodgrass. Good old Snodgrass. Yeah, I know, it's Snodgrass. That's a name. Anybody know who Snodgrass is? I'm going to find out who Snodgrass is. Huh? From a novel. Huh? I got to look up Snodgrass. Darn. uh, um. Anyway, Snodgrass is a fictional character in a novel. The Snodgrass clan. It's a Scottish name, Snodgrass. Anyway, I've heard it from a novel. Sorry. Good old Snodgrass. The proportion of college students who have a TikTok account is what? 70%. You guys okay with that? As claimed, I'm going to highlight this, by Snodgrass. So Snodgrass is making an educated guess. Let's translate this. What do you think? P equals what? 70%. Put the word claim next to it because this is what Snodgrass is claiming. So this is your claim. This is your hypothesis, ladies and gentlemen. Okay, Snodgrass is making that claim, 70%. Now, when you set up your hypotheses, you have H0 and you have H1. Where do you think this belongs? Is this a null or is it an alternate? So put it in the null position. You guys okay with that? Easy peasy lemon squeezy. Okay, you guys okay with that? All right, now. What did I just say about these about H0 and H1? These are logical what? Opposites. So this will be a not equal. The opposite from equal is not equal. So you just set up your hypothesis, ladies and gentlemen. You just set it up. Now, if you look at the alternate hypothesis, okay, and you see a not equal, this will always, always, always be what? A two-tail what? Test. So we're going to try that out. This is what's known as a two-tail test, ladies and gentlemen. So you might say, what do I have to look at? The alternate hypothesis, the inequality there. Now, the next step is to create a decision rule. All that is a normal distribution, the bow-shaped curve, that Z distribution. It's the standard normal, so you guys know, where the mean is 0 from the standard normal distribution. Standard deviation is 1. It's a bow-shaped curve that this is completely based on. It's based on, estimation was based on the same thing. Like if you said to me, hey, Mr. Judge, in estimation, this is like a two-tailed test, sort of. Okay. But there's more information here. This is just setting this up. To create the decision rule, they're going to have to tell us. They're going to have to say something like this. They need more information, and they'll give it to you. They're going to say, use the 5% level of significance. You're going to see this phrase. That phrase, ladies and gentlemen, level of significance is defined. We got to talk about that. Is alpha. Okay, alpha is 5%, which is 0.05. So let me go back to my notes. But what I'm going to tell you guys is this is related to your confidence level. It's actually the complement of it. And it's the area in the tails here. 5% is in the tails. So I'm going to say this alpha is the area in the tails. It's really the percent of the ballot shaded. But if you have a two-tailed test, half of alpha is in each tail. So you might say, okay, half of 5% is 2.5%. .5% goes in here. 2.5% goes in here. You guys okay with that? What's the complement of that 5%? This is 95%. So you guys remember when we were talking about confidence level? Okay? They're the complements of one another. So estimation and, in fact, estimation and hypothesis testing are two sides of a coin. On one side, you have estimation. The other side, you have hypothesis testing. So if they say use the 5% level of significance, we'll talk about that in more detail. I'm just having to share with you guys first how you create the decision rule. Okay? You draw your bell and you use your level of significance. That's the sum of the tails. Half is in each because this is what's called a two-tail test. Draw two tails. Now we're not done. We're almost done. But is everybody okay with what I'm describing at this point here? Okay, that's 2.5% plus 2.5% gives you what? 5%. What we're going to have to do is label, ladies and gentlemen, we're going to have to label these regions. In the center, this is do not reject the null. This is your center region. The tail, you're going to reject the what? No. So you're going to have two regions here. The do not reject the null region and the reject the null. This is always what you have. So if I go back to my notes, the beautiful version, you might say, Mr. Judge, is this what you're trying to describe in that ugly version? Yeah. Do not reject the null right in the middle. And then reject the null for your two tails because this is a two-tail test. This is that purple region. Now, you might say to me, but what does CV stand for? Do you guys know what CV stands for? Here's what they say. In my notes, alpha represents the level of significance, and it is the sum of the percent of the ballot that is shaded in the tails. Critical values are determined by our Z table. Oh, not anymore. Critical values are determined by our what? Z table? No. Let me cross this out. Those nice critical values that separates the rejection regions from the do not reject regions, those critical values used to be done by the Z table, but they're now going to be done by the what? TI calculator. You say, Mr. Judge, what is that? We're going to use inverse what? Norm. Inverse norm. We're going to use the inverse norm key to find critical values here. And by the way, you might say, hey, Mr. Judge, on our test and final. No, I think, where is it at? Here. Remember I let you guys use this summary sheet? See the summary sheet? Yeah, it has formulas. I have to update the formulas, and then, oh, I got my language, and then I have what? TI calculator stuff. So really, this is our first kind of hypothesis testing is going to be about a proportion. And what I'm sharing with people, how do you get critical values, is to use what? The inverse norm. So this is why I created this sheet for you guys. So if you go, what if I forget, Mr. Judge? Well, I'm going to tell you guys, don't forget. But if you do, you have this summary sheet. How do you remember? You got to do problems over and over again, different examples, and I'll give you those different problems and everything. And then you know what to do. You do it in your sleep. You guys don't know, I left my coffee on the table, and this morning, and I'm still asleep. So I'm lecturing in my sleep. But you might say, well, how could you do this? Because I've done it over and over again. So if I said to you, how do we use inverse norm? This is the formal definition of alpha. I don't go over the formal definition before I go over problems. I just share with you guys the informal. It's the sum of the tails. But there is a formal definition of alpha. You can read about that, level of significance. Anyway, there's the z-table. We don't use you anymore, z-table. And what was our alpha in this example? You see, your level of significance is going to be 10%, 5%, and what? 1%. Now, remember this is related to confidence levels. It's the complement. Okay, that's really what's going on. It's the complement. It's the other side of the coin. Well, for confidence levels, we did it with 99%, 95%, and 90%. Now, I had a great questions because somebody said, why use 95 and 99 and 90% confidence, right? Well, the media uses 95% confidence by default. But remember, where does some of that 95 and 99 really come from? Remember, we have these likelihoods of something greater than 95%, which meant it's almost what? Certain. So it really comes from some of those definitions, like it's almost certain your mean will be between these two numbers. That's why you have 95 and 99%, right? And you go, what about the 90? Well, it's not almost certain, but it's still pretty high probability. So why you care about 90, 95, and 99 for confidence levels is because it's centered around the idea of almost certain. You know, you care about these higher probability values, almost certain, although 90 is not almost certain, but it's still high probability. Now, what do you say? What does that have to do with our level of significance? It's the complement of that now. 10, 5, and 1. And it really has to do with what's known as the modern method. It has to do with this definition of significance level and what it truly means about type 1 and type 2 errors. But you've never done a test yet, so I can't even talk about the details of this yet. So that's why I don't. But somebody might have that question. So here's what I'm doing now. Remember with alpha being 5%, and yes, the confidence level was now what? The flip side of this, 95, right? You know what the critical values are? Negative 1.96 and positive 1.96. You might say to me, why? Well, what did we say? You're going to go to the inverse what? You can go to the TI. See, I was doing, no, I wasn't. That was part of my calculus lecture. Sorry. Second distribution. Where was inverse norm? Number 3. Now, here's the deal. Remember, everybody has, or people have different TIs. You see the area is 2.5%, and mu is 0, sigma is 1. Everything you have here is fine. What you need to enter and think about is it this way, area to the left of this value. Right? This is going to be that 2.5%. So the critical value they're talking about in the TI is area to the left there. So if I now hit what? Paste and enter, I get negative 1.96 to the nearest what? Tenths. And so you might say, Mr. Judge, is that why it's negative 1.96 there? Yes. Remember the default calculator? Do you guys remember what I'm saying? What if I have that other version, which is like, it looks more like this, and then I go to the inverse norm. I go second distribution, inverse norm. You only have what? Area. Well, it's the area to the left, 2.5%. If it's alpha is 5, your mean is 0. Standard deviation is 1. It's the standard normal distribution. It's your z distribution. You get that negative 1.96. So I'm just kind of letting you guys know, both with the modern TI and the older one, you get the same answer. But what if I decided to enter what here for inverse norm? You said, Mr. Judge, I want to put the 5% with a z distribution, mu is 0, sigma is 1, but I'm saying that that's in my center, 95% of the area there in the center. Isn't that what you guys see in the picture? Right? Right in here? Guess what your TI does? Paste that in. It gives you both answers. So if you put the center area, which is the same as the confidence level, by the way, negative 1.96, positive 1.96, you're going to get the correct critical what? Values. These are called critical values. Then you got to do the left default. If the calculator doesn't do center, the default is right, was what I started with. So even in some of the other classes, I don't even talk about center because I don't want to confuse people, because sometimes people might say, that confuses me. So I'm just going to give them the default on the left. Default on the left. You say, well, what if my alpha is 10%? Well, alpha could be 10%. But if you have two tails, how much is in each tail? How much is in each tail? If the level of significance was 10%, what is half of 10%? Do you guys know how to do that? What's half? You take half, divide by 2 the 10%, and what does that give you? Isn't that 5%? So you might say, how do I get this by the default? Well, area to the left there is 5%. So you're going to go to the TI now. Second distribution, inverse norm. Okay, 5%, because alpha is 10, mu is 0, sigma is 1. That is the area in the left tail. So I'm saying calculator, 5% is in my left what? Tail. And that's true when alpha is what again? 10%. So when I hit enter, I paste that in. What do you guys got? Negative 1.6 what? 0.645 to the nearest what? Thousandths. Is that right? So if you said to me, why is the critical value here negative 1.645? Well, that's because they used inverse norm. They actually used the z-table, but we're not doing that anymore. Why do I get the other one on the other side? Because of symmetry. There's two tails, and then there's going to be two critical values. So, ladies and gentlemen, this is again what you guys want to what? Do. Two-tail test. Alpha is 1%. 1% love of significance. What is 1/2 of 1%? Isn't that point what? 5%? As a decimal, that's 0.00 what? 5. That's how much is in each tail. 0.005. So if you said to me, why is it for those level of significances, I'm going to do the default again. Area to the what? To the left. So ladies and gentlemen, this is how they get those critical values. And I'm going to use the default version, right? I'm going to say second distribution, inverse norm, and that's going to be 0.005 mu 0 sigma is 1. It's the z distribution. And what do you end up getting? That's negative 2.57 what? Well, if I go to the nearest what? Tenths, isn't that negative 2.57, negative 2.58? This is why those critical values are what they use. And there's two because there's two tails. So what I'm saying to you guys is this. I'm showing you guys the informal relationship in that the level of significance, alpha, is really the sum of the tails, which is the complement of the confidence level. You say you had a 99% confidence. Well, alpha is 1%, 1% level of significance. It's a coin. On one side, you have estimation based on a sample, and the other side, you have hypothesis testing based on a sample. And then we'll dive deeper into the alpha meaning as you guys get more confidence and experience with the process. But if you said, how come these critical values are there? Because they use the inverse norm key. Okay? All right. Now, there is a right tail task. We're not going to talk about that today. There is a left tail task. We're not going to talk about that today. But I wanted to express to you guys, in this example, what were the critical values of 2.5%? You guys remember? How did you get it? Because that was what this was. Second distribution, inverse norm, 0.025, because that's in the left tail. We're using the default just to kill two birds with one stone for everybody. And this is why it's negative 1 point what? 96. Sorry. Because there's two critical values here. You can get rid of this here. Okay, I'm going to summarize that here for you guys. Alpha is what? 5%. All right, you guys okay with that? So this is your decision rule. I know it's your first decision rule. And when you first see it, you say, what? I understand that, but you have to do what? More examples, and you have to do more questions, and then pretty soon you can do it in your sleep. I've had a lot of people successful with this material in the past, and they had to use like Z tables and calculators that weren't TI. So they had to really dive deep into the formula. We're not going to use a formula. We're going to use a TI. Now you might say, how do I do that? What comes next in the process? Yeah, it's like step 3, and I'm going to look for my sheet. Where is that step 3? Step 3. Somewhere over here. Oh, yeah. We need more space. Step number 3. We'll do it right here. Step 3. Really, you take a sample to compute your test statistic. So, here's step 3. Take a what? Sample, and you're going to compute a what? A test statistic. This is why they call the course statistics. And you say, what's a test statistic? It's a single value that represents the sample. It's a number that's representing your sample. And that is historically based on a formula. I won't show it to you now, but we're going to use the what? TI. We're going to use what's called 1. In the TI, it's called 1 proportion Z test. That's step number 2. So take a sample and get the number that represents the sample, called a test statistic. It's like that's the number that summarizes this. Step 4, determine where your test statistic lives on the what? Decision rule. And in there, and that's pretty much it. But here's the thing, right? Okay. You need more information. Because you guys can write that down if you haven't, right? So you're going to take a sample. That sample is going to be used to find the test statistic value. It's a single number that represents the sample. And once you find that single number, see where it lives in your decision rule, you're done. So let's go back to our nice question here, which is, hey, what % of college students have a TikTok account? Here's what you guys need to do. You're going to say a sample of 120 college students. Doesn't that kind of seem familiar? A sample of 120 college students reveal that 80 have a TikTok account. Isn't that very similar language to your estimation sample? It's exactly the same language. So if you guys did estimation, do you guys remember I give you guys a little estimation extra credit to get you what? Started so you don't procrastinate. I don't want you guys procrastinating because then, woo, so I try to motivate you with extra credit. That's the motivation. Oh, don't forget. Because I might give you a similar one for hypothesis testing. Why? So you don't what? Procrastinate. When you try to read it the night before a test. I had a student, he told me he got upset. He dropped my trig class. Because I tell students things that are the truth. I'd rather people tell me the truth. I don't want people lying to me. I don't know how you guys feel. Do you guys want people lying to you? I tell the truth. I don't do it to be mean. I just do it because it's true. If I say, hey, don't wait before the night before a test to start to do anything. Because if you do, it's too late. And I went further. I said to the class, I've said to my students for over 20 years. If you do that, you might as well just go out to dinner and what? The movies and have a good time. Personally, that's how I see it. Because if you say, no, I'm just not going to sleep tonight, I'm going to cram it all in, all is going to be good. No, it ain't. It's just not. I wish if that were the case, I would say it. Yeah, just cram the night before, everything's going to turn out. I know from experience, it doesn't. It just doesn't. Not with math and statistics. Maybe your driver's ed test. I don't know. You guys know what I mean? Maybe you're, I don't know. Have you ever taken a class where that works? Some. I think I took a health class. I memorized all my vitamins the night before. And on the multiple choice test, it was like, I got it. I think I've done it, but not very often. I've learned my lesson. I'm not going to do this thing. I better learn it ahead of time. So that's the advice I give. He was like, you can't tell people to go to the movies? Really? Why not? It's odd. You're offended because I said go to the movies and said, you don't do your homework, so go to the movies instead? And that offends you. Well, sorry. Oh, well. Guess you're sensitive. I don't know. Is that offensive? I don't find it. I don't know. I don't do it to be offensive. I just do it because I think it's true. It's like, why would you just go have a good time? Who knows? I just think people are funny. No big deal. So remember, have you read this before? What's my point? Your estimation homework has the exact same language. So if you went over and over an estimation, you say, oh, that looks familiar. What does 120 mean and what does 80 mean? Sample size. And what's this? Those are the successes. That's not sample proportion. So in the sample, what's the deal? Sample size is 120. The successes is what? 80. To get the test statistic, what do you guys need? Run proportion Z what test. Be careful here. I'm going to share with you guys how to do this. It's very simple. Okay, I know it's a long day, but we want to get one in and, of course, we'll do more. So you're going to go to stat, go over to test now. That summary is in my notes for you guys, but I'm going to share with you guys that. Where's one proportion Z test? Is that number 5? Now, what do you guys see there? You see this P naught? That's the one thing I have to tell you what it is. Yeah, you see that first one? Yeah, I know. Look at the first line. It says P naught, right? So go back to your setup of your hypothesis, okay? Go back over here. You know what P naught is really? P naught is the proportion in your null hypothesis. This is that P naught they're talking about right here. It's like saying, hey, What was the proportion in the null hypothesis? Oh, what is it? 70 what? Percent. So in your calculator, put 0.70 for 70%. Now, go further. What is X? Remember, for estimation, isn't that the number of successes? That's how many students had a TikTok account. That's 80. What was the sample size? 120. You guys okay with that? So you put the P naught, you put the X is 80, N is 120. You see this not equal? You know what that really is? Well, if I go back all the way to what? Remember we said this is the two-tailed test. We said this is that P naught right in here, right? This number here is P naught. Oh, sorry. This is P not equal to the P naught in the calculator. This is really just code for, see that proportion not equal to P naught? That's code for just a two-tailed test. So the not equal is a what? Two-tailed test. So all you do is go down now to what here? Calculate, ladies and gentlemen. And what do you guys get? You get what? The Z value here is what? That's your test statistic. Negative point what? What do we approximate? The second number here. That's your test statistic. If you go to the nearest hundredths, isn't that negative 0.80? What is that? Yeah, we'll talk about that one. Let's go back over here really quick. I'm going to share with you guys what that is. You know that Z value you got? That's the test statistic. Yeah, that Z value of negative 0.80 to the tenths, the second number, that is your test statistic value. That's what you're looking for. Your test what? That number, test statistic. Negative 0.8. So you might say to me, what do I do with this number here? Well, where does it live? This is step 4 on your decision rule. Where does that thing live? Let's see. Where would negative 0.8 be? I want to say this to you guys, that any Z value between your critical values of negative 1.96 and positive 1.96, you know what you do? You do not reject the null. So negative 0.8 is like somewhere over here. You guys agree with me on that one? You got to see where that test statistic lives on your decision rule. So negative 0.8 is in where? What neighborhood? It's to the left of 0, but it's not past 1.96. Think of it as money. 80 cents versus 1.96. It's not past it. So what neighborhood is this in? What does it say? Do not what? Do not reject your null. You're in the do not reject the null neighborhood. So go all the way down over here. And I'm going to say, write that down. Do not what? Reject the null. So finally, step 5 is your conclusion step. We're not really finished. There's one last thing we have to say. It's a formality. We're not rejecting the no. Here's your conclusion. There's only one of two conclusions you're going to have. Here's what you're going to say. The sample is either going to support the claim or the sample what? Does not support the claim. There's two options you're going to have for conclusions. Okay? There's going to be two formal conclusions you have to have. Either the sample supports the claim or the sample does not support the claim. Okay? But in order to determine that, you're going to go through a process. This is probably the hardest part for some people. But it's not that hard. You know why it's not that hard? They're not following my instructions. And they don't know the meaning of the word reject and not reject. So I'm going to share with you guys this, okay? It's not that hard. You guys can do this. Have you ever been rejected? Let's take a look in the room. Have you ever been rejected? You have? What does it mean to be rejected? Huh? Yeah, what does it mean to be rejected? You're like, say, look at the formal meaning of rejection.
Yes.
You're like pushed aside, you're pushed out. You're rejected. Isn't that horrible? You got rejected. Like if, for example, you got person what? Person A, there's only two people. Person B. If you reject person A, what are you doing with person B? Right? Well, okay. This is what I'm saying. People don't keep it simple, right? This is a real scenario. I hate to say it. Sometimes you're in the situation where you have two choices. Either person A or person B. The smartest is reject them all. Sometimes we're not that smart, though. We're human beings, and sometimes, yeah. So, rejection means get rid of. What does do not reject mean? Keep. Thank you. Do not reject means to keep. All right. You guys ready? If it says do not reject the no, go back to your statement here. It's simple, but people get it wrong. Do not reject the no. Where is your no? Right here. I'm going to circle this. You know why I'm going to circle it? Because I'm not rejecting the what? The no. I am keeping the no. What does that mean about the claim? Remember this. I'm going to go back and do it again. Do not reject the no means I'm keeping the no. What happened to the other person? Goodbye. Oh my God. It's not even my computer. Let's talk about rejection and what happened. What's going on? Anyway, my computer, let's do this here. Okay. My computer's fine. Thank God. Don't even want to think of what can don't even say it. Don't even say it. I don't want to go to the Apple store. Ah!
It might have a video
I don't think it is me. It's it's the projector. And right when I got to the good part. Okay. Well, here's the thing. You guys watching the video. You have to see it. Darn it. Do you guys remember what I circled? What did I circle? I did. But where was the claim? Did you notice that I circled the what? The null. Is that true? Did you guys notice I circled the no? Then what that means is, since I circled the no, you guys can see just a little of it there, right? I circled the claim. So I'm keeping the what? I'm keeping the claim because it was circled. The claim was circled. That's the key. That's why I put it in red and I label it. So because you circle the claim, ladies and gentlemen, you can watch the video at the end. Here's our conclusion. What we end up saying here is what? The sample what? Supports the claim. I'm going to check something here. So the sample supports the claim here, ladies and gentlemen. Go back. What did I keep? I kept the null. That happens to be the claim. It's that simple. It's that simple, ladies and gentlemen. Did you circle the claim? So what does that mean? That means that the sample supports the what? Claim. That's your formal conclusion here. That's the formal hypothesis test. This is like the first test you guys ever done in your life. I understand it's a long process. I got to go through all the nitty gritty. And there it is, ladies and gentlemen. The sample supports your claim. Yes.
Is the claim always the null?
Never. I'm sorry. No, sorry. Sorry. Hold on. Don't do that.
What do you mean?
Don't go there. I'll answer your question. No. The claim is not always the null. Somebody can think of remember, this is all somebody's claim. They can think of an alternate statement. It could be not equal. And what I usually do is I show people another example and I go, what if somebody made the claim where it's not equal? Now the claim is the alternate, right? So don't assume, and that's where some people make their mistake here, is that your claim is always the null. Your claim could be an alternate hypothesis.
How do you know which one to change?
Say it again.
How do you know which one to pick?
What do you mean?
Between the null and the alternate?
Well, like for example, if I said to you this, right? I mean, we can't do that, but I mean, what if I said to you as an example, right? I can say, here's Snodgrass again. Snodgrass is saying what? The proportion of students who believe in ghosts is not 50%. Okay? as claimed by Snodgrass. So you go, the proportion of students who believe in ghosts is what? Is not 50% claimed by Snodgrass. So what would you write down? P is not equal to what? But make sure you write this down too, next to it. Why? Because that is the claim. As claimed by who? Snodgrass. That's really what you're testing. You're testing that statement here. Okay? Now remember, when you set up your hypothesis, what's the deal? Where does that go? That goes down here. Is that true? So this person made a claim that happened to be called an alternate hypothesis. That's all. It's an H1. The claim is an H1. You don't always say it's a null. So, okay. So then what's the deal? The opposite is this 50%. Okay? You with me on that? You guys okay with that? Now, just as a hypothetical, we're not going to go through the whole information. Remember this thing? What goes in the middle? Do not what? Reject the null. And over here, what do? Reject the null. Okay? Remember this? It's a simple thing, but be careful here. Be very careful. Don't oversimplify it. And yes, we have critical values. Yes, you can say, is there a critical value here? Yes, and a critical value. Yeah, there's some alpha, whatever that is. Who cares? But it's all based on your what? Test statistic. Take a sample, compute that test statistic. What if your test statistic lives right here? Okay? What is the story here? Yeah. Well, hold on. Stop right there. It means do not reject the null. It means to do what?
So is it saying to keep or to not keep the claim?
No, don't use that word claim. If you ever notice, this is always what phrase? The null. The null. So be careful here. This is why it's a very delicate thing. Your sample is saying essentially this: do not reject the null. The sample is saying that the proportion is 50%.
So it's just wherever that value lands is where it dictates.
It's going to dictate whether you keep the null or reject the null. See how I'm saying null? I don't say claim. The null. And you say, why? Because that's the decision rule. It's based on the phrasing the null.
So then we do all this just to know whether or not we keep or get rid of the null, and then the alternative is just there as in, even if it's the claim, what we're looking for is the null.
Well, what this example is saying, since we're not rejecting the null, we are keeping the null, we are getting rid of the alternate. So that means the sample does not support the claim. So it's this is what I'm saying from my experience all these years. This is going to be a place where some people have some confusion. And you might say, why? Because people assume your claim is always the null. That's why. And
the claim is initiated in the question itself.
That's right. And so this is why when I share with you guys the process, right? When I say, okay, you know why? Write down the claim. Some people don't do that, and then they have no clue what the conclusion is. So write down the claim. So it's going to go back to that sad situation. Do you keep person A or keep person B? If you keep person A, you get rid of person B. You don't keep them both. If you keep person B but get rid of person A, there's only one statement that the sample is really going to represent. So all this is really saying at the end of the day is that the data you collected is suggesting that the proportion is 50%. But that is not the person's what? Claim. You go, but Mr. Judge, how do I know what the person's claim is? Because they're going to tell you. Proportion is not 50%. That's what Snodgrass says. Guess what, Snodgrass? We can tell Snodgrass. Snodgrass, the sample does not support your claim. So Snodgrass was what? Wrong. And that's the essence of this, is like people make these statements, but go out and get a sample, compute to test statistic, and verify. Is that statement what? Valid? Or is that statement what? Not valid. Now, I'm not using the formal language here, but the formal language is exactly that. Did your sample support the claim, or did your sample not support the claim? So this kind of hypothetical situation is saying, guess what, Snodgrass? Sample does not support the claim. In fact, the sample is suggesting the proportion is 50%. Now, it's not here. Well, this is a different question. But somebody asked earlier, hey, what was that P hat here? Remember this in the last one? Someone asked what? Go back to you see that P hat? That's about 67%. So the prior example we did, the sample proportion is at 0.67. So people, remember that third line there that the question was I wanted to get back to? That's your sample proportion, just like before in estimation. You know, they didn't ask you for it, but it is 67%. That's the last example. But ladies and gentlemen, that's, again, don't oversimplify it. What you want to know, this is why I always write this phrase down. You know, here, the test statistic is in the do not reject what? The no. Because the decision rule is based on saying no. It's not saying claim. Saying no. It's not saying claim. You guys see that there? I don't even look. You know, it's funny. When I do all this, I don't even look at the claim at all. All I do is go back to my null and go, hey, no, we're not rejecting you. That means we keep you. And then I go, oh, by the way, where's my claim at? It was an alternate. Sorry, you're gone. If it's gone, the sample does not support the claim. But if it's kept, like in the prior example, Mr. Judge, the claim was kept. The sample supports the claim. That means the sample is suggesting the proportion is 70%. Now, this is the first set of examples you guys have tried. So when you first see it, it does knock you around a bit. You go, But you have to see what? More examples. And after you see more examples, you start to go, oh, yeah, okay, I see what's going on. And then you do it in your sleep. But you imagine if you waited till the night before to figure it out? That's why I say go to the movies, because you're going to have a better time. Go see what's out right now. Me neither. I don't even go to the movies anymore. Anybody here go to the movies? One person goes. What's out right now? Did you get some popcorn and everything? Have a good time? I used to be a big movie person. I used to own Blu-rays and And what else? Blu-rays, huh? Well, actually, CDs. Not anymore. Everything's in the cloud. What do I do with all my old Blu-rays? I keep them. What does my wife say? She wants me to get rid of them. She wants a yard sale. Do you see why I don't talk to her? It's like those are my Blu-rays. Get rid of them. What? Have a yard sale. What? That's why.
I have my aunt and my grandma. They live together. She's only a year older than me. They have this entire shelf
Yes.
of DVDs.
Yes.
And
That's me.
my old computer used to have a DVD player.
Mhm.
So if there were movies I couldn't find on any streaming service or I had to pay for it, like rent, I would just pick up a camera of that for a couple days.
Exactly. You can check it out from grandma. You know, here's the thing about her. It's kind of interesting, though. It's odd. I'll share with you guys this thing. She doesn't watch movies. Isn't that weird? That is weird, isn't it?
Like she doesn't watch them through.
She doesn't watch movies. In fact, she doesn't like go to the movies. She doesn't watch movies. She's not a movie watcher. If she had to sit down and watch a movie, chances are she won't finish it. And if she did finish it, she won't watch it again.
I'm always like that.
Yeah.
Is she an introvert person? Sometimes they have better things to do. That's what they think.
That's what they think. Like, I'm going to go rearrange the garage.
Yeah.
Yeah. Oof. But you did that last week. So I got to do it again. I'm like, what are you hiding? What are you hiding? You're not dealing with something. There's a psychology major in the back. Is that a sign of somebody not dealing with some reality that they really need to deal with? Not always. I'm just wondering what that means. I'm like, what are you hiding? Why do you gotta paint the kitchen again a different color? You did that already 3 times. It was yellow 4 months ago. Now you want to paint what? I have no idea. It's kind of weird. Isn't that weird? How about this one? Who eats spaghetti without sauce? Exactly, like 2-year-olds. Put a little butter and cheese and that's it. No, I think, you know what it is? I think she just never grew up eating spaghetti. And it's so, what? Alien. Like spaghetti. But you know what's interesting? She's changed. Because that first time I did my secret weapon. Made my spaghetti. Did your dad make spaghetti? Yeah, we all do. All dads make spaghetti. That was my secret weapon. I thought she was joking. I said, she's seen. I said, I'll have some without sauce. I thought she was just joking. Now she's eating. Now she eats it. But you know what's funny? I almost made the comment to her yesterday in dinner. Remember I said I took my daughter to dinner? You know what I ate? I took her to a Japanese restaurant. And I ordered, what is that? The curry, the soup though. You know, the noodles and soup, curry udon. I ordered curry udon. Pretty good. You know what she wanted? She wanted to eat my curry udon. I said, go right ahead, have some. Eat all you want. See, I'm not a bad guy. I shared my curry udon. She could eat as much curry udon. But what I noticed, has sauce. There's some sauce in that thing. It's all sauce because it's soup. Well, if I said to her, as I thought of saying, I guess you like sauce now, don't you? I thought of saying that, but I didn't. I was like, that's a good boy. I'm not going to say, I noticed you're eating a lot of sauce over there in my curry udon soup. I'd get in trouble. Yes, she'd get mad at me because I find her contradictions.
It could be something she never exposed to, and then that's what
She never exposed a curry either. Look, I love curry. I love Japanese curry. I used to eat it like 3 times a week. I love it. My daughter loves it, and now my wife's eating it. But because that dish, but people don't realize, I've had to convince my own family, that dish is eaten throughout Asia. That's a lot of people enjoying curry. You know what I mean? So it's a very popular dish. In fact, in Japan, that's their like national dish. Did you guys know that? So when they look at me weird because I go, I'm going to eat some curry, they go, oh, wait a minute. This is a very popular dish throughout the world. And people love it. I love it too. And now they love it. Isn't that interesting? But it's pretty saucy if you ask me. Yeah, I didn't bring it up. Sorry. Okay, you guys. What I'll put online here some of your homework you could get started. I might even put some videos for you guys if you want to see more examples. Okay, you guys, you know what I mean? So like in Canvas, a lecture here, I did that for the other class. This is really Statistics Lecture 14. Okay. But it's the start of Statistics Lecture 14. But I'll send to you guys in Canvas because you might have gotten very excited about this stuff. Just like me. No. Oh. Just like me. See, and I even put, what did I put here? This is a summary. This is on your, this is a sheet you guys can use on your test and final. So you make hypothesis testing about a proportion, critical values, inverse norm, one proportion z-test. I really wish things would work. I wonder what happened there with that. Maybe it was on too long. So you guys can get started, and then you guys see the little TI video there? I'll show you guys the TI video. You got your tutor. Right? You go, no, that's not. It's another class. So you see all these tutors? These are some various different hypothesis testing. This is about a mean. This is about a proportion. What is this? 2 proportions. So we're gonna head that there. This is, we have various video TI version to help you, but we just got started because there's different tests. So you guys can see some of these things here. We just got started there in some of this. But I might, like I said, I do have some video files using this as well. I might send you guys as an announcement or something. You know what I mean? And then if you said, I got excited about this, I want to get started, because I think this weekend I'll send you another extra credit. For what reason? To help you not procrastinate, because you don't want people to procrastinate, because that's like the worst you can do. It means 1 through 8. Just means 1 through 8. Anyway, so I'm not so bad. I just don't want to argue. Because when you get old like me, you start to realize there's very little to gain by arguing. You might as well just what? Enjoy and not argue. You don't argue with your mom. No, sorry, my wife. I'm sorry, not my mom. Sorry. Freudian slip. I don't even argue with my daughter anymore. It's okay, Ashley. Whatever you say, you're a big girl now. Okay, you guys. We'll see you guys later. Have a great day. I'll see you guys later. Let's find out how to turn this nonsense off.